Hello students, welcome to my channel RAM Civil Tutorials. In this video, I am going to discuss about compressive strength of concrete. If you are watching my video for first time, please subscribe my channel. So this class will help you for your academics and engineering entrance examinations like Ecet and job examination at state level, that is AE and AWS, and job examination for national level JE, SSC JE and RRB JE, and all other civil engineering related competitive examinations. So let us start our today's class. So there is a compressive strength of a concrete. Before discussing that, I will discuss what is the strength of a concrete. What is the strength? Before that, what is the strength of any material? Strength means it is ability to resist the deformation. A deformation may be a cracks or a deflection. If the deformation occur due to a compressive forces, then I can say compressive strength of a material. So with this concept, I will define what is the compressive strength of a concrete. It is ability to resist the deformation due to specific compressive forces which are applied over the concrete members. So this is called a compressive strength of concrete. Generally, this compressive strength of concrete, it depends upon the following parameters. Say water cement ratio. So you know if you increase the water cement ratio, the strength of the concrete decreases. If you decrease the water cement ratio, strength of concrete increases. And one more parameter is strength of a cement. If the strength of cement is increases, as you know that our cement is used as a binding material in the concrete. So if the strength of cement increases, strength of concrete also increases. And it also depends upon the fineness of cement. So you know the fineness of cement means the how much fine powder we have. That is nothing but a fineness of cement. So if the fineness of cement is more will be the compressive strength. How it is more? So you know that a heat of hydration process. Because of that only the strength will gain by the concrete. So the hydration, what is the hydration process? Hydration means a reaction of water with any other material. Here in the concrete, water will react with the cement. That a process is called heat of hydration. It evolves the heat that will generate the strength in the concrete. So more the fine of cement, the surface area of the cement will be more. So that more surface area will attract more water. So there will be more development in the heat of hydration. Then the strength will be generated more in the concrete. That's why your compressive strength of concrete is depends upon fineness of the cement. And also it depends upon quality of a concrete material. You know what are the concrete materials what you are using? That is cement, coarse aggregate, fine aggregate and everything. If we are using superior quality of material, then obviously the strength of the concrete also increases. And finally, it depends upon quality control during the production of a concrete. Yes. So if you maintain a good quality control during the production of concrete, obviously it will increase the compressive strength of concrete. Then how to determine this compressive strength of concrete? So this can be determined by conducting compressive strength test on a concrete samples. So this compressive strength test can be done with the IS specifications of IS 516. So for performing this test, we required some samples, and those samples are made in the shape of cube and cylinders. And cubes we are using in Indian standards, cubes are used 150 mm by 150 mm by 150 mm, and sometimes use 100 mm by 100 mm by 100 mm also. But our code recommends, as a Indian standard IS code, it recommends use only this type of cubes, that is length 150 mm, width 150 mm, and depth of the cube is 150 mm. This cube will be used for determination of compressive strength of concrete. And cylinder also used, but in India we are not using a cylinder for determination of compressive strength of concrete. This is used in ACI standards, that is American Concrete Institute standards. American code will follow for calculating the compressive strength of concrete by using cube. They are using standard standard cylinder, that is 150 mm in dia and 300 mm in height. This cylinder they are used for determination of strength of the compressive strength of the concrete. So now you have to calculate for determining the compressive strength of a concrete. We have to determine what is the surface area of the cube. So surface area means on which area of the cube we are applying the compressive force, that is called a surface area. So this is the surface area now. This is length into width, that is 150 by 150. If you are using 150 mm cube, then surface area of that cube would be that is 22,500 square mm. Right? So what is the test procedure is? Here this test procedure conducted in 3 stages. One is sample preparation, second one is curing stage, and third one is a testing stage. So what we'll do in sample preparation stage? You know the grade of concrete, based on the grade of concrete we have a mixed proportion. Say mixed proportion means it is a mixture of cement, coarse aggregate and fine aggregate, in which parts we can mix the concrete, that we know prior to the compression test, conducting compression test on the concrete. Say we have to prepare the concrete first, and that concrete will be prepared based on the mixed proportion given and grade of concrete we are designing, and then we have to fill that freshly mixed concrete into the concrete molds, that may be in the shape of a cube. The cube generally what we are used is 150 mm by 150 mm by 150 mm in size, and this will be filled in 3 layers, and for these 3 layers will be compacted by giving the number of strokes with the tamping rods. That number of strokes should not be less than 35 in each layer. After finishing of 3 layers, then you have to level to the top surface and smoothen it with some trowels. After smoothing with the trowel, then we have to keep this sample aside for 24 hours, and after 24 hours you have to detach these iron molds from the concrete. Then mold will be hardened somewhat. That hardened mold will be placed in the curing. This is called a curing stage, and this is a curing pond here. In curing pond you can see here so many numbers of samples. These samples may be cured 3 days, 7 days, 14 days and 28 days. Generally we will conduct the test on each cube on 3 days, 7 days, 14 days and 28 days. The temperature to be maintained in a curing pond, that should be 27 degrees plus or minus 2 degrees. Generally we can say the room temperature we have to maintain. So this is the curing stage. So if you want to test your sample in 3 days, 7 days, 14 days and 28 days, you can take out the sample from this and go for testing. So the next phase of the determination of compressive strength of concrete is a testing. This testing can be done based on the compressive testing mission, or we can say universal testing mission. Here I have given CTM and UTM. CTM stands for compressive testing mission. UTM stands for universal testing mission. You can use any one of the mission and for performing compressive strength on a concrete. So you can test the samples in 3 days, 7 days, 14 days and 28 days. And while here so you can see clearly how the sample will be placed in the compressive testing mission. Here we have a bottom level surface and top loading plate. On bottom loading plate we have to place our cube, and from top loading plate we have to exactly place that on the exact in contact of a concrete specimen. Then we have to apply the loading onto the cube. The loading must be applied at a rate of 140 kg per centimeter square. So here we have a surface area. Over that surface area of the cube, you have to apply the load. For every minute you have to apply 140 kg per centimeter square, and that load must be applied not suddenly. The load must be applied gradually. How to apply the load? Load must be applied gradually. Don't forget, it is very important question for your competitive examinations. The rate of loading which is applied over the compressive test on a concrete is 140 kg per centimeter square per minute. That is, gradually we have to apply the force. So these are the 3 stages: stage 1, stage 2 and stage 3. You know what the first stage is? In first stage, we have to prepare the sample, and then second stage, the prepared sample must be cured for 28 days to maximum, and third stage, after the curing period is over, that sample will be taken to the laboratory and we have to test its compressive strength. Right. Now, how to calculate the compressive strength? The compressive strength of the concrete can be calculated by using this formula, that is maximum load at which sample fails by surface area of the cube. So you know, after applying the load, the sample will fail at some loading. That load is called a failure load. The load at which sample fail is called a maximum load, which can be applied over the sample, and if you divide that load by surface area of the cube, that will give the compressive strength of a concrete. Generally, that can be measured in terms of kg per centimeter square or Newton per mm square. So here I have some sample calculation, the how to calculate the compressive strength of a concrete. What is the compressive strength of a standard cube of concrete which fails at 400 kilonewton? You know what is the standard cube as per IS 456-2000, that is 150 mm by 150 mm by 150 mm. So if that cube is tested under the compressive testing machine, the compressive testing machine will show the maximum load is 400 kilonewtons. So you know the formula for calculating what is the compressive strength of a concrete is, that is maximum load at which sample fails by surface area. The maximum load it will fail is 400 kilonewtons, here 400, and it is given in kilonewtons, so I have converted into newtons, so that's why I multiplied with 1000, and surface area is one side of the cube is 150, another side of also 150, so 150 by 150, I will get finally the compressive strength of a concrete is 17.7 Newton per mm square. Right. So this is how we calculate the compressive strength of a concrete. So you know we'll see the compressive strength of concrete at a different age. So if you test your sample after 1 day of curing, it will gain the strength 16% of its total strength. After 3 days, it will gain 40% of its total strength. After 7 days, it will gain a 65% of total strength, that is almost 2/3 of total strength. In 14 days, if you test the sample, that will give 90% of its total strength. In 28 days, we will get the maximum strength, that is 99% of strength. That will be the final strength we can assume for our design. So if you clearly observe this table, see this is the first week. If you see the first week of that is 1 to 7 days means first week. In first week you are getting the compressive strength of concrete is more than, that is 2/3 of total strength. So we are getting maximum strength in the first week of the concrete, first week of casting of the concrete. In after second week we will get 90%. So what is the difference from first week to 7th week? It is almost a say 25% here. And from third week to fourth week we are getting only, there is increasing in strength 9%. So from that you can clearly say that the strength of concrete increases very rapidly in its initial days. So it is the first week of that we will get almost 2/3 of total strength, and from 14 days to 28 days just it was increasing 9%. So from that I can say the first week, first days, that initial days of concrete casted, it will gain its maximum strength. So it will gain its strength very rapidly at initial days. Right? Now, so let us discuss what is the characteristic compressive strength of concrete. Generally in our RCC design, the compressive strength of concrete can be represented in terms of its characteristic compressive strength of a concrete. So what is the characteristic compressive strength of any material? So the definition given by IS 456-2000, it is the value of strength of material below which not more than 5% of test results are expected to fall. What do you mean by this 5% of test results are expected to fall? Say if you take any material, if you want to check the strength of that particular material, and that strength of particular material you want to say it is a characteristic strength of that particular material, then let us consider a strength of a particular material is X. You have prepared 100 sample for that particular material to know the strength of that particular material. In that 95% or 95 test samples must reach the value of X or more than the X, and the allowable failure must be 5%. Then the value what were obtained for 95% of test sample, that value is termed as a characteristic compressive strength of a material. Similarly, I will define what is the characteristic compressive strength of a concrete. See, it is the compressive strength of 150 mm cube at 28 days curing. After testing, we will get the strength of that concrete in Newton for mm square, or we can say it is in terms of MPa. Those samples should not fail more than 5%. The remaining 95% passed samples strength what we have, that strength will be considered as a characteristic compressive strength of a concrete. Generally, it is designated with a letter called FCK. What is that? FCK. That is a characteristic compressive strength of a concrete. Now, will I explain you clearly what is the meaning of a characteristic compressive strength of a concrete. Say you are designing a concrete for M20 grade. By using this M20 grade concrete, you have prepared 100 cubes, and these 100 cubes are tested under the compressive testing mission or universal testing mission. If the strength of more than 95 cubes are greater than this 20 MPa, that is 20 Newton for mm square, then you can say the characteristic compressive strength of that concrete is what? M20 or 20 MPa or 20 Newton for mm square. So this is the actual meaning of what is a compressive strength of or characteristic compressive strength of a concrete. So as initial stage of this class, I have told you that samples can be prepared in the shape of cube or cylinders. And if we compare the strength of cube and cylinder, the compressive strength of cylinder sample is 80% of a compressive strength of cube sample. Why? Now, compared to the cube, your cylinder is a slender member. So it is because of slenderness ratio of this cube will fail early under the load. So then we will get only 80% of strength compared to the cube. Right. Next, we will discuss some questions which are asked in competitive exams like SSC, JE and Ecet examination based on this topic. So the questions are like this. The first question is, the characteristic strength of a concrete is defined as the compressive strength below which not more than that of. So it is a basic definition given by characteristic compressive strength of a concrete is, for a concrete, the characteristic compressive strength is, it is a compressive strength of 150 mm cube at 28 days curing in Newton for mm square. Those test sample should not fall more than 5%. How much? Not more than 5%. Test results are expected to not more than 5% of test results are expected to fall. So the options are given that 2% of test results, it is not correct, and 5% of test result, so it is the correct answer. So the option is B for this question. It's a basic definition. It is a very important question. So many times, multiple times this question are asked in various civil engineering competitive examination. So what is that? Finally I am defining. The characteristic strength of a concrete is defined as the compressive strength below which not more than 5% test results are expected to fall. Right. Let's go for next question. The strength of concrete mainly depends on. The options are like this. Quality of fine aggregate. Yes, the strength of concrete is dependent upon quality of aggregate, and water cement ratio also, and fineness of cement also, and quality of coarse aggregates also. So in the given options, all four options, our strength of concrete is depending. Then how to choose a correct answer? You know the word called mainly among all these four options, which option our concrete is mainly depends. So here the first option say quality of fine aggregate. If the quality of fine aggregate is good, then the strength of concrete also good. And water cement ratio, if you increase the water cement ratio, strength of the concrete decreases. If you decrease the water cement ratio, the strength of concrete increases. And quality of coarse aggregate also. If you use the quality of coarse aggregate, then the strength of concrete also increases. Moreover, if you take the surface area of this coarse aggregate, that will be less compared to the finer materials, and then we'll get the lesser surface area. So more water we have to form a cement gel, so that we will get the bonding properly. But the correct option is fineness of cement. What is that? Fineness of cement. So what is the reason being a answer is fineness of cement? You know, the major attribute which contributes the strength of concrete is the reaction called hydration. This hydration is the reaction is between cement and water what we added in the concrete. So because of the heat of hydration, strength will be generated in the concrete. So the more the fine the material, more will be the surface area, and the water what we added, it will having contact with the more area, so that the heat of hydration process will be more. So the strength gaining will be more rapid in the concrete. That's why more the fineness, more the surface area, so more will be the development of a concrete strength. That's why fineness of concrete is the correct option in this among four options. Dear students, don't confuse with that. These four are on these four options your strength of concrete is depends on, but mainly which option it is depends upon is the fineness of cement, because the reason is how the strength will gain the concrete because of hydration process. The hydration process will be developed between your cement and the water. So for the cement, if the more the fine the cement, more will be the surface area. So if the surface area is more, then this higher water will be contact over the more area, so that strength will be gained more. That's why fineness of cement is mainly depends upon strength of the concrete, or the strength of concrete is mainly depends upon the fineness of the cement. So this question was asked in SSC JEE exam 2015. Just one more important question. IS has specified the full strength of concrete after. Read out the question carefully. IS has specified the full strength of the concrete after 7 days, 14 days, 21 days and 28 days. So you know, as for IS 456-2000, the maximum strength gained by the concrete is in 28 days, that is 99%. Okay. So this question was asked in SSC JEE 2008. So let's solve one more question. See, the concrete cube prepared, cured and tested according to the standard code number is. Here we have IS 515, IS 516, IS 517 and finally IS 518. So here the explanation. The IS 515 is used for natural and manufactured aggregate for use in mass concreting. So IS 515 is not correct. And we have IS 517. It will give the specification for the methanol preparation. So IS 517 is not so correct, and IS 518 is not related to this. The final answer would be the IS 516 is methods of test of strength of concrete. So this IS 516 is the correct answer. According to this question, the option B is correct. Right? So see here one more important and interesting question. The compressive strength of 100 mm cube compared to 150 mm cube is always less, always more, or equal to that, or none of the above. Right? So to answer this question, here I have an explanation. So you know what is the stress means. Stress is nothing but force per area, unit area. From this equation, you can say that our stress is inversely proportional to area. So, means, what do you mean by this? If stress increases with decreasing in area. What do you mean by stress? It is an internal resistance. So, more the internal resistance, more will be the strength. That we know that. More the internal resistance offered by the body, so that we can say that is that much stronger. So, stress is nothing but a internal resistance of the body, and internal resistance nothing but a strength. So, here stress is increased with decreasing in area. From this I can conclude that our strength of the member or strength of the concrete is increased with decreasing in area. So here in the question they are given 100 mm cube and 150 mm cube. The surface area of 100 mm cube is say 10,000 mm square, and the surface area of 150 mm cube is that is 2,25,000 mm square. If we compare this, the surface area of 100 mm cube is less than surface area of 150 mm cube. So this is mm here, please note it down, 150 mm cube. So according to our principle, the strength is increased with decreasing in area. So the area of 100 mm is less, so strength in the 100 mm cube is more. So the compressive strength of 100 mm cube is more than compared to the 150 mm cube. So answer is B for this question. And you can explain other reason for this also. So if you prepare the section with more dimension, there may be a chance of more voids in the concrete section. And if I prepared a concrete member with a lesser section, so there may be a chance of lesser voids in the smaller section. So if the more voids, that will give the lesser strength, and lesser voids, that will give the more strength. So the section 150 mm is more than the 100 mm. So there may be a chance of having more voids in this 150 mm cube than the 100 mm cube. So the less voids we have in this 100 mm cube, the strength of this 100 mm cube is more. In this way also we can answer this question, right? And the next question is, it is very important question, a tricky question. The concrete attains a major part of the strength in. This question was asked in SSC JE 2007. So we know the table that for one day we'll get 16%, for the third day we'll get 40%, in 7 days we'll get 65%, in 14 days 90%, and 28 days 99%. Read out the question. Concrete attains is major part of its strength in. Major part of strength in 1 week, 2 weeks, 4 weeks, and 5 weeks. So 5 week is not at all a matter, as we are doing 28 days means 4 weeks. So we can easily discard this option. So remaining left with 3 options, 1 week, 2 weeks, and 3 weeks. In 4 weeks we will get a maximum strength, total strength of the concrete. See, the question is major part of the strength. Then the option remaining is 1 week and 2 weeks. See, if you observe this table, the major part of the strength will be gained, that is almost 65% of strength are gaining in first week of preparation of a concrete. So within 1 week we will get major part of the strength. So the answer for this question is 1 week. So the option A is correct. So thank you. Please subscribe my channel for more updates. The best is yet to come.